Hey folks, this calculus lesson is on, this is part 3. I have a part 2 that I had lost in my computer somewhere. I'll dig up, so if not, I'll just rebuild it. Anyways, this is part 3, more optimization application problems. Let's go ahead and begin, you guys. So a man in a rowboat, he's 2 miles out from the shore and wishes to get home as soon as possible. If his house is 6 miles down the shore and he can row at 3 miles per hour and walk at 5 miles per hour, how far should he walk and how far should he row? All right, well, let's get a picture of this sense right here. Okay, so here's my little dude rowing right here. All right, so he's 2 miles out from the shore right here, okay, and he's 6 miles down of the shore. His house is right here. So somewhere he's going to row this distance right here and walk the rest of the distance right there. So what I'm going to do is let this be x right here, and this little piece is going to be 6 minus x. You guys with me? Okay, because it's the rest of the 6. And then use a little bit of Pythagorean theorem right here. We have a right triangle here. 2 squared plus x squared equals this hypotenuse squared. So square root that, and you get square root of x squared plus 4. Okay, you guys with me? Okay, so that is my rowing distance right there. Okay, this is my rowing distance. All right, recall distance equals rate times time. And so how far should he walk and row? So he wants to, we want to solve for time because we want to minimize the time. He wants to get there as soon as possible, so we want to minimize the time. So I solved this for t, and this is the formula I'm going to do. I'm going to differentiate this one right here. Okay, now I got a time for this rowing right here, and I got a time for this walking right here. So it's going to be, and remember, the rowing, he goes at 3 miles per hour, so it's going to be distance divided by 3 on that one, and for the walking, it's going to be the distance, 6 minus x divided by 5, okay, because time equals distance divided by rate. All right, so the row time is going to be, I'm sorry, the row time is this distance divided by the rate, and then the walk time is this distance divided by the rate. Okay, so that's what I'm going to differentiate, you guys. So here we go. Do a little u substitution for this radical right here, and I let u equal the inside stuff, so du is 2x. All right, so I get y equals u to the 1/2, and when I take the derivative of that, it becomes 1/2 u to the negative 1/2. All right, which is 1 over 2u to the 1/2. Don't forget your du goes on top. So here's my du on top over 2 root u on the bottom, 2u to the 1/2 right there. All right, and don't forget the 3. There's that 3 right there, that 3. Okay, and the derivative of this guy is negative 1/5 right there. Okay, and then I set it equal to 0 because once you take your derivative, then you set it equal to 0 to get your critical. All right. Okay, and here I have a proportion now, and I added 1/5 to both sides. Now I'm going to go ahead and cross multiply. Okay, to get rid of that radical, I'm going to square both sides right there. So I got to square the 3 also, and it gets rid of the radical. And then square the right side, I get 25x squared. Okay, and distribute the 9 through. All right, and then subtract 9x squared from both sides, and I get 16x squared equals 36, and divide by 16. Um, Actually, yeah, and then 4 goes into both of those also, you guys. 4 goes into 16 4 times, and 4 goes into 36 9 times. So then divide by 4 and take the square root, and you get plus or minus x equals plus or minus 3 halves, or 1.5. Okay, now x is distance, you guys, so it's just going to be x equals 1.5. Okay, I don't need to worry about the minus part right there. Okay, and I plug this into my derivative formula right there. So I plugged in x equals 1, and I found out it's a negative. When I plug in 1 right there, 1 squared plus 4 is 5, and then 1 right there. And then when I take off 1/5, it gets me a negative. And when I plug in x equals 2 right there, I get a positive on this side. So it's going down, then it goes back up. So this is a minimum spot right there, and that's what I wanted, is a minimum, you guys, for minimum time. So if he walks, I'm sorry, if he x equals 1.5, which is in that picture, you guys. Let's go back. The x was 1.5. Okay, so there's x right there. So that's 1.5. So 6 minus 1.5 is 4.5. All right. So he's gonna row 1.5 miles, and he's going to walk 4.5 miles. Okay, or he's going to row downstream 1.5 miles. Okay. X equals 1.5 miles. For row time, actually, this should be a little bit off. The row distance is the square root of this guy squared plus 4. So this is wrong right here. All right, so it should be row is the square root of 1.5 squared plus 4. Okay, and then so he's going to walk the 4.5 miles. Alrighty, make sense, you guys? Okay, so my answer's off just a little bit right there. I didn't catch that until right now. All right, so this one takes a little bit too, you guys. A 4-foot wire is to be used to form a square and a circle. Okay, how much of the wire should be used for the square and the circle to enclose a maximum area? All right, so we got 4 feet of wire right here. So this is 4 feet of my wire right here, and it's going to be separated up into a square and a circle right there. All right, so so this 4 feet of wire right here is going to be my square, which is 4x right here, and then my circle is 2 pi r, okay, because the circumference of a circle is 2 pi r. All right, and then what I have to do now is we've got to maximize my area. So here's my area formula right here, x squared plus pi r squared. All right, and then I'm going to go ahead and solve for r so I can get everything in terms of one variable right here. So what I did is I subtracted 4x on both sides and then divided by 2 pi, got me to this, and then I divided everything by 2 and got me to this right there. So that's my radius right there. Alrighty, and then so that radius is going to go into my area formula right here. Okay, so there's my radius squared. So there's that the radius squared right there. All right, and then I'm going to square that. Getting kind of messy, I know. All right, so when I square that, square 2 is 4, square the pi is pi squared, and square this binomial gets me this trinomial right here. Okay, this pi is going to cancel out one of these right here. Let's see, is that what I did? Yep. All right, and then now that's what I'm going to differentiate right there. I'm going to take the derivative of that. Okay, so the derivative of x squared is 2x, and then the derivative of negative 2x is negative 2, and the derivative of this is 2x. Okay, you guys with me? And then what I did is I pulled out a negative 2 right there, so it changed that to a negative right there. All right, and then so I am over here. All right, so I don't know why I pulled out negative 2. I should have just left it distributed through. I distributed this back through right there, and I get this right there. Now I'm solving for x, you guys, because this is my derivative, and I'm solving for x and making it equal to 0. Okay, so I'm going to add the 8 over pi to both sides. Okay, you with me right there? Now I'm going to pull an x out of both those guys. So when I pull an x out of both those guys, I get that. And then I'm going to divide by this quantity right here, and I get that right there. You with me? Now I'm going to clean it up a little bit. I don't like fractions and fractions, so I'm going to multiply everything by a common denominator, which is pi. So times pi, this times pi, this times pi, and what happens is it cleans it up nicely, see? And then so I take that up here, right here, so I get 8 over 2 pi plus 8, and divide everything by 2, and I get 4 over pi plus 4. All right, when I put that in my calculator, I get about 0.56. All right, now when I put test 0.56 with my derivative function right there, it ends up being a minimum, you guys, and the problem's asking for a maximum. So this doesn't work, you guys. So what am I going to cut it, you guys? Now think of, because of the square is, the perimeter is 4x, so my domain restrictions are x has to be between 0 and 1 because it's only a 4-foot wire. Okay, so that's my domain issues is it can be a maximum of 4, or I can have I can even have it to be 0. So I'm going to test x equals 0, because I already know x equals 0.56 is a minimum. So I'm going to test my endpoints, x equals 0 and x equals 1, into my area function right here. So I did that over here. Okay, so I plug them in, and so when I plug in x equals 0, I get the area is 1.273. And when I plug in x equals 1, I get 1. So my maximum area is when x equals 0. So when x equals 0, that's when I don't have a square and all the wire is used for the circle. Alrighty, that's a challenging lesson, I know, you guys. Okay, if you're in my calculus class, I'm going to assign you guys that for your homework. Take care.